Welcome geometry students to the review sheet help video. Hopefully this video will be a help to you guys. If you have any questions on this review sheet, I hope that you will watch these problems and it will help you find your mistakes. Let's go ahead and get started with numbers 8 through 13. Okay, the directions for 8 through 13 say, tell whether the point, line, or segment is a chord, secant, tangent, diameter, radius, center, or point of tangency. Okay, so number 8 is segment BN. Alright, now here's segment BN. Here's the end point. Here's the end point. Here's the segment. Hopefully you recognize that as a diameter. Okay, so number 8 would be a diameter. Okay, number 9 is point N. Point N. Well, here's point N right here, and notice we have a line that's hitting that point right on the circle and then continuing on, and so we call that a point of tangency. Okay, anytime you have a line tangent to a circle, where that line is intersecting the circle is called your point of tangency. Okay. All right. Now segment BF. Let's look over here. Okay. Now remember, please listen to me carefully. Notice number 10 is not saying line BF. There's a segment right here. It's segment BF. And so it's referring to the segment from here to here and nothing else. Well, students, anytime you have a segment inside of a circle, that has its endpoints on the circle, we call that a chord. Okay, that is a chord. So segment BF is a chord. You say, well, Mr. Earhart, BN is also a chord. Yes, it is, and I have no problem with that. But BN is also a diameter because it is a chord that goes through the center of the circle. Okay, so BN is a chord. It's also a diameter. BF is a chord. Now, point D is what we call the center of the circle. Here's point D, it's the center of the circle. And then line CN. Now that's line, notice the symbol there, line CN. And so this line right here, CN, is a line that's intersecting the circle in one place. So we call that a tangent line, okay? So this is a tangent line, or just tangent. And then BF, that's line BF, notice the symbol. Well, line BF is a line that's intersecting the segment in two places. And we call that a secant line or a secant, okay? A line that intersects the circle in two places. Now, not a segment. We're not talking about a segment that has its endpoints on the circle. This is line BF, which is a whole line that goes through the circle and intersects it in two places. We call that a secant. Okay. All right. Moving on to numbers 14 through 16. 14 through 16. The directions say to find the value of R. Okay. Now don't forget, anytime that you have I'm looking at the directions here. Notice the directions say that AB is tangent to circle C. So we know that we have circle C. We know that this line right here is tangent to the circle. And listen to me, students, anytime you have a tangent line, which we have, and a radius drawn to the point of tangency, you will always have a right angle right there, always. So what that tells me is I have a right triangle right here. And so I'm going to cut that right triangle out, and there it is. And now if you'll look here, I know this segment is 8 from this right here. I know this segment here is 10 from this right here, and they want us to find R, which is one of your legs. So students, we really should know by now, if you have a right triangle and you know two of the sides, you find the third side by using Pythagorean's theorem. So one of my legs is R, my other leg is 8, and my hypotenuse is 10. So then I would have R squared plus 64 equals 100, and then subtract 64 from both sides, and I would have R squared equals 36. Take the square root of both sides, and R equals 6. Okay, let's apply this to number 15. Now number 15, notice I've got a tangent line. okay? And I have a radius drawn to the point of tangency. So as soon as you see that, you realize you have a right angle right here, okay? So if we have a right angle there, then that means I have a right triangle. And so I've kind of done the best I can to draw that right triangle and cut it out. This is a length of r, your hypotenuse has a length of 26, and your leg has a length of 24. Okay, so once again, it's a replica to the other problem. You have a leg of an r, a leg of 24, and a hypotenuse of 26. Now I'm going to grab my calculator here real quick, and I'm going to square 24, and I'm going to square 26. All right. Now if I do that correctly, I'm going to get r squared plus 576 equals 676. Now subtract 576 or bring the 576 over and make it negative, and you'll be left with r squared equals 100. Now take the square root of both sides and you will get 10. Okay, so once again, what they're drilling into your heads here is whenever you have a tangent line and a radius drawn to the point of tangency, you will always have a right angle. Okay? Now let's take a look at this last problem. And again, it's really being redundant, but we'll do this last problem quickly. Notice I have a tangent line here. I have a radius drawn to the point of tangency right here. So what I know is I have a right angle right here. So what I'm going to do is I'm going to quickly cut the right triangle out like I always try to do so we can see the right triangle, and then label the correct sides according to this 17 here. The hypotenuse is 17. According to this 15 right here, the leg is 15. And now I'm all set. This is my r right here, so I'm all set to use Pythagorean's theorem and solve this right triangle. So I'm going to square the leg, and the leg will be r squared. I'm going to square the other leg, it'll be 15, and then I'm going to square the hypotenuse, and that's going to be 17 squared, okay? So with my calculator here real quick, I'm going to do all of that, and here's what we are left with. We are left with r squared plus 225 equals 289. Now, if you bring the 225 over and make it negative, you're going to be left with 64, and then take the square root of both sides and you will get 8 for the length of r. So there we go. Now moving on to number 17 through 19. The directions read A and D are both segments that are tangent. Find the value of x. Now here's what they're reviewing for you in numbers 17 through 19. What they're reviewing is this. Anytime you have two tangent segments coming from the same exterior point, those two segments will be congruent. So do I have a tangent segment here? Yes. Do I have a tangent segment here? Yes. And they both come from the same exterior point. So B, I'm looking at my book here. This kind of got cut off in the picture. I apologize. If you'll look in your book, you'll see there's a point D right here. Well, segment AB has to be congruent to segment AD because of a theorem that we learned, and I'm paraphrasing it, but if two segments are tangent to the same circle and they come from the same exterior point, those two segments are congruent. So if the length of AB is 6, the length of AD also has to be 6. So x equals 6. All right, let me get a drink here. Moving on to 18. Again, it's the exact same thing. This is a tangent segment. This is a tangent segment. They're both tangent to the same circle, and they both come from the same exterior point. So segment AB has to be congruent to segment AD. So I can take 2x plus 1 and set it equal to x plus 7. Now bring your x over and make it a negative x. Bring your 1 over and make it a negative 1. So this is gone. This is gone. 2x minus x is x, and 7 minus 1 is 6. So the answer to x has to be 6. Okay? Moving on to number 19. Same problem once again. And I do apologize again for this picture being cut off, but this segment here is a tangent segment. This segment here is a tangent segment. They're both tangent to the same circle, and they both come from the same exterior point. So segment AB must be congruent to segment AD. So I can definitely state that 3x minus 4 equals x plus 10. Now bring your x over and make it a negative x. Bring your negative 4 over and make it a positive 4. And you're left with 2x equals 14. Now we divide both sides by 2 and x equals 7. Now again, what they're reviewing in these three problems is very simple. Anytime you have two segments that are tangent to the same circle and they both come from the same exterior point, then those two segments will be congruent. Okay? All right, let's jump on now and look at numbers 20 through 25. Numbers 20 through 25. Now, in these types of problems here, I've taught you students in the past, the best thing to do instead of trying to look at each arc that they're asking you to find and then find that measure, that's really not the best way to solve this type of problem. On a test or a quiz, I would recommend that you just simply go through and find as many of these as you possibly can and just kind of fill in the rest as you go. Okay, for example, let me show you what I mean. Right here, in the directions, they tell us that AD is a diameter. So I know this is a diameter right here. If you'll look in the directions, you'll see that, okay? Now, if that's a diameter, then you know this arc right here has to be half of a circle, which is 180 degrees. So I know if I take arc DC, which is 59, and arc AB, which is 36, if I add those together, I'm going to get 95 degrees. Well, I then take 180, and by the way, why is arc DA 180? Because it's half of a circle. A diameter always cuts a circle in half. So if I take 180 and subtract 95, I'm going to get 85 degrees. Okay, so now I know arc CB has to be 85 degrees. And if you want to check that, then with the calculator, take 59 plus 85 plus 36, and you will get 180. Now, also notice in the directions, they tell you that arc CE is 121. So let me change colors here, and let me show you something. From C all the way to E is 121 degrees. They tell you that in the direction. So students, think about it. If I know from C to D is 59 degrees, and I know from C all the way to E, this whole arc's 121, I'm going to take 121, I'm going to subtract 59 degrees, and I'm going to get 62. Okay? So now I know arc DE is 62 degrees. And you say, Mr. Hart, are you sure? Yeah, let's check it and see. If I took 62, which is arc DE, and I added that to 59 degrees, which is arc DC, I'll get 121. And in the directions it says arc C to E is 121 degrees. Now think about it, students. Look, we only have one arc left. And that's from here to here. Well, you know a complete circle has to be 360 degrees. We know that. So I'm going to take my arc here, which is 62, and my arc here, DC, which is 59, and arc CB, which is 85, and arc BA, which is 36. I'm going to very quickly add those together. I'll get a 22, carry a 2, 8, 13, 21, 24, and I'm going to check and make sure this is right. 11, 20, 22, 11, 16, 20. Yes, that's right. So if I add up all of the arcs that I know, it's 242 degrees. And we know a circle all the way around has 360 degrees. So I'm going to take 360 and subtract out 242, and I would get, I think, 118 degrees. I did that quickly in my head. Let's see if that's right. 0 carry, yeah, that's correct. So there we go. So instead of looking up here, students, and trying to find arc DE or arc AE or arc BCD, I just went around and found all the arcs. Now I can very quickly, using this information, go through and answer each question pretty quickly. For example, number 20, arc DE. Okay, well here's arc DE from here to here. And so that would be 62 degrees. Next, arc AE. Okay, fine, here's A. And follow that all the way along to E. So there's arc AE. And obviously that answer is 118 degrees. Now let's do arc AEC. Okay, start at A. Go to E. And then go on to C. There we go. Arc AEC. So that's just going to be 118 plus 62, which is 180, plus 59, that's going to be 100, 200, 239 degrees. So I just took 118 plus 62 plus 59, and that's going to give me 239 degrees. Now, number 23. Let's find the measure of arc BC. Well, here it is. Here's B, moving along to C right here. Well, that's going to be 85 degrees. So the answer is 85. Now they want us to find the measure of arc B all the way to D, all the way to C. You must follow the orders in letter. It must follow the letters in order. So we're going to go from B to D and then to C. Okay? Now some of you might have gone this way, but as soon as you did that, then in order to go to C, you'd have to go all the way around again to C. So you should have realized you would be wrong. So you're going from B to D, then to C. Not B, then to C, and then to D, but B, then to D, then to C. Well, I could add up 36 plus 118 plus 62 plus 59, and that would give me the answer. But I've got a faster idea. Notice arc BDC goes from here all the way around to here. And so why not just take 360 and just subtract out the only arc that's left, which is 85 degrees. And if you do that correctly, you will get 275. So then you know if you add 36 and 118 and 62 and 59, you will get 275. So the answer is 275. And then last but not least, arc BDA. Well, students, first of all, you understand you definitely don't want to start here at B and go to D this direction here, because if you do that, then next you go to A, you're going to circle all the way around and like have an overlapping arc right here. So as soon as you see that, you know you're going the wrong direction. So you want to start here with B, go to D. I need to change colors here, something bright. Let's start with B. I'm going to go all the way to D. So from B to D, and then from D on around to A. So there we go. There's arc BDA. So really I could add 85 plus 59 plus 62 plus 118. If I did that, I would get the right answer, which is 324, and that's fine. No problem with that, but there is a faster way. Notice arc BDA is the entire circle except this little bit right here. So you could just take 360 and minus 36 degrees, and if you do that correctly, you will get 324 degrees. Okay, so the answer is 324. Okay, moving on to numbers 26 through 28. 26 through 28, and the directions read: find the length of the red arc. Round your answer to the nearest hundredth. Okay, here we go. Now in your notes, I broke this down into two steps for you. Anytime you're looking to find not the measure, but the actual length of an arc, I gave you two steps. Step one was to find the circumference of the circle, which is 2 pi r. Okay, so 2 times 3.14 times the radius, which is 3. So with my calculator, I'm typing this in, and I'm getting 18.84. So there's step one. I found the circumference, 18.84. Then next, I said to find the fraction of the circle that you're dealing with. Well, you're dealing with 50 degrees over the whole circle, which is 360. In other words, this little wedge right here that forms this arc right here, you're dealing with 50 out of 360 degrees. And then, of course, if you reduce that, you're going to get 5 over 36. So step one was find the circumference. We did that. Step two was to find the fraction of the arc that you're dealing with, and you're dealing with 5/36 of the entire circle. And then I told you to multiply these two together using a calculator if you want to. That's totally fine. So with my calculator, I'm going to take 5 over 36 times 18.84. And to have a decimal answer is fine. I'm getting 2.62, which is the correct answer. And of course the answer is going to be in inches, and you know that because your radius was in inches. So the length of this arc from here to here is 2.62 inches. Now it would not be inches squared or inches cubed because you're not dealing with area and you're not dealing with volume, okay? But that's the length of the arc. Let's try the next two a little faster, but don't forget the two steps are find the circumference of the circle, then find the fraction of the circle you're dealing with, and then multiply those two together. Okay, number 27, going a little faster. First of all, let's find the circumference. Circumference equals, you can actually use pi d also, so you're welcome to use 2 pi r. That's totally acceptable. Or you can use pi d. I'm going to use pi d this time. For pi, I'm going to substitute 3.14. And for the diameter, I'm going to put 16. Now remember, if your radius is 8, then your whole diameter all the way across would be 16. Okay? So that is where I got the 16 from. Now, with the calculator, I'm going to type in 3.14 times 16. And you will get, for the area, you will get 50.24, or not the area, the circumference. So the circumference of the circle is 50 over 24. Now step two, find the area of the circle. Find the area of the circle that you're dealing with. That'd be 120 degrees over 360. So if you reduce that, you will get 1/3. Okay, so I'm now going to take my circumference times 1/3. Okay, and let's see what we get. Okay, I'm getting out 16.75. They have 16.76, and both answers are totally fine. So the answer would be 16.76. And we know that it's in centimeters because your radius was in centimeters. Okay, moving on to number 28, going a little faster now. Let's quickly find the circumference of the circle. Circumference equals pi d. So for pi, I'm going to substitute 3.14, and for the diameter, I will substitute 10. If the radius is 5, the diameter is 10. 3.14 times 10 is 31.4. So there's your circumference. Now let's find the area of the circle that we're dealing with. That's going to be 100 over 360, and if you reduce that correctly, you should get 5/18 for the area of the circle that we're dealing with. Okay, or the part of the circle we're dealing with. So we're going to take 31.4 times 5/18, and if we do that correctly, I'm getting 8.72. They have 8.73. More than likely, they're not using 3.14. They're probably using their pi button on their calculator, which is fine. I'm not going to be that picky. The answer I'm getting is 8.72, and it would be meters because your radius was in meters, 5 meters. Okay, so there's the length of this chord, or of this arc right here. Here's the length of the arc right here, 8.72 meters. Okay. All right, moving on to numbers 29 through 34. 29 through 34, they're telling us to find the value of x. Okay, find the value of x. Okay, I'm going to give you a lot of review information, so please listen carefully. There is a theorem that we learned that said if two arcs are congruent, then the two chords that make up these arcs, this chord here and this chord here, they will be congruent. So how do I know that arc AB is congruent to arc ED? Well, here's how I know. Notice the central angle right here. Let me change colors. Notice the central angle that makes arc AB. There's the central angle right there. Okay, and then notice the central angle that makes arc ED. It's the central angle here. And notice something about these two central angles. You should see it, don't you? They're congruent angles. We have one mark here and one mark here. So think about it. If I have two central angles that are congruent on the same circle, then that means their arcs are going to be congruent. So I definitely know that this arc here, arc AB, is congruent to arc ED. And we have a theorem that says when two arcs are congruent, then their corresponding chords will be congruent. So I know that segment AB, that chord will be congruent to chord ED. So I can definitely state that x plus 5 equals 8. Now bring the 5 over and make it a negative 5, and x equals 3. Okay, moving on to number 30. Okay, now let's think this through again. This is the exact same problem, identical. Are you ready? Watch. Here's a central angle here, and notice it's 90 degrees. Here's a central angle here, and if it's 90 degrees here, then it must be 90 degrees here. So what that means is this central angle right here is 90 degrees, and this central angle here is 90 degrees. So that means the arcs that central angle ACB formed, chord AB, is going to be congruent to chord BD. So this chord here is congruent to this chord here. Now we have a theorem that states when two arcs are congruent, then their corresponding chords are congruent. That means chord AB and chord DB are going to be congruent. So I can definitely state that x plus 1 equals 4x minus 5. Now bring the 4x over and make it a negative 4x. That would give you negative 3x. Bring the 1 over and make it a negative 1. That would leave you with negative 6. Divide both sides by negative 3, and x equals 2. Okay, number 31. Okay, now listen to my reasoning carefully, please. Do you see chord ED? Do you see chord AB? Notice they're congruent. Now we have a theorem that states when two chords are congruent, then their corresponding arcs are congruent. So we know that arc ED is going to be congruent to arc AB. So I'm going to go ahead and put some marks there. Put 2 marks through arc AD and put 2 marks through arc AB. Now we know that when an arc, let me start over. We know that a central angle, like this central angle here, is always congruent to its arc. And we know this central angle here, the measure of it, is congruent to its arc. So think about it. If this arc here is congruent to this arc here, then this angle here has to be congruent to this angle here. So I can definitely state that 2x equals 70 degrees. Divide both sides by 2, and x equals 35. Okay, moving on to number 32. Okay, here's what we learned in a previous theorem. What we learned was if you have a diameter and a chord that are perpendicular, the chord will be divided up into Let me say that again, sorry. If a diameter and a chord are perpendicular, there we go, sorry about that. If a diameter and a chord are perpendicular, then the diameter will divide the chord evenly. In other words, it'll be a segment bisector. Let me say that again. If a diameter and a chord are perpendicular, then we know that this segment here will be congruent to this segment here. So, do I have a diameter? Yes. Do I have a chord? Yes. Are they perpendicular? Yes. So I know that segment DF is congruent to segment EF. So if EF is 6, then DF has to be 6, so X equals 6, okay? All right, number 33. Okay, number 33. Let's take a look at this. Let me turn back in my book here to the correct page where I was. Okay, now, the theorem they're reviewing on number 33 here is simple. If a diameter is perpendicular to a chord, then it bisects the chord, which we looked at one problem ago right here, but it also bisects the arc. So let me say that again. If a diameter and a chord are perpendicular, the diameter bisects the chord, it also bisects the arc. So do we have a diameter? Yes. Do we have a chord? Yes. Are they perpendicular? Yes. So the diameter bisects the chord, but it also bisects the arc. That means arc DB is congruent to arc EB. So if DB is 60, then also EB must be 60. Okay, that's number 33. Now number 34. Okay, let's take a look at 34. Okay, now the theorem they're reviewing here is this theorem, okay? If two chords are congruent in the same circle or in congruent circles, then their corresponding minor arcs are also congruent. So let me show you something here you need to see. First of all, do you see how this segment from here to here has 2 marks? And do you see how the segment from D to this point here has 2 marks? Well, let's just make some numbers up. Let's say they have a length of 6 and 6. And then notice how this segment from here to here has 1 mark. And notice how the segment from here to here has 1 mark. Well, that means they're congruent. Let's say those have a length of 4. So this segment here is 4, and this segment here is 4. Well, that means this entire segment is 10, and that means this entire segment here is also 10. So do you see, it doesn't matter what numbers you choose, these two chords will be congruent. So we have 2 chords that are congruent that are intersecting inside of a circle. So, with that in mind, anytime 2 minor chords are congruent, okay? Anytime 2 minor chords are congruent, then their corresponding arcs will also be congruent. So, watch this very, very carefully, please, okay? If I take the arc from here to here, which would be the arc of this chord right here, I have 115 plus 55, which would be 170 degrees, okay? Then if I take the arc from here to here, that would be the arc of this chord right here. So it should also be 170 degrees. So if this much here to here is 55, then this X definitely has to be 115 degrees, because 115 plus 55 will be 70 degrees. Okay? Hope that made sense. Moving on now to the next set of problems. Now for numbers 35 through 37, the directions say find the measure of the angle, the inscribed angle, or the intercepted arc. Now remember, what they're reviewing in these 3 problems, 35, 36, and 37, is an inscribed angle is always half as big as its arc, or the intercepted arc is always twice as big as the inscribed angle, however you want to say it. So notice I have an inscribed angle right here. That means all three of these points are on the circle. 1, 2, 3. If this arc is 106, the angle is going to be half that, which would be 53 degrees. So the answer is 53. Okay, number 36. Notice here they give you the angle. So here's your inscribed angle right here. Notice the inscribed angle is 39 degrees. Well, here's the arc that is intercepted for your inscribed angle. So if the angle is 39 degrees and the arc is twice as big, 39 times 2 is 78 degrees. And then lastly, number 37, same thing. Here's your inscribed angle, and your inscribed angle is 100 degrees. Now the intercepted arc runs from here to here, and so the intercepted arc is twice as big as the inscribed angle. If the inscribed angle is 100, then the intercepted arc would be 200 degrees. Okay, moving on to numbers 38 through 40. Find the value of x and y. Okay, now listen to me very carefully. All right, number 38. We did learn a theorem that taught the following. Okay. If a triangle is inscribed within a circle, then the hypotenuse is going to be a diameter. Okay, let me say that again. If a triangle is inscribed in a circle and it's a right triangle, then the hypotenuse is a diameter of the circle. Now we also learned the opposite of that. Okay, if you had to listen to this carefully, students, if you have an inscribed triangle, and we do we not? And one of the sides is a diameter, which is what we have, right? We have an inscribed triangle, and one of the sides is a diameter. When that happens, then you know for sure you have a right triangle. And obviously this is your bigger angle. This is going to be your right angle right here. Let me say that again. If you have an inscribed triangle, and we do, and one of your sides is the diameter of a circle, which it is, then you know that you have a right triangle. So this is 52. You know y is going to be 90, and then add those two together, you'll get 142. And so this right here has to be 38 degrees, because 38 plus 90 plus 52 is 180. For the third time, I'm going to say it again. Whenever a triangle is inscribed in a circle and one of its sides is a diameter, then you know that you have a right triangle, and the diameter is going to be the hypotenuse, so this has to be your right angle. Okay, number 39. Okay, now here's what we learned. Okay, we learned that whenever a quadrilateral is inscribed within a circle, opposite angles are always supplementary. So this angle here and this angle here are supplementary, and they're going to add up to 180. So this would have to be 68 degrees, because 68 plus 112 is 180. Now, these two angles here that are opposite each other are going to be supplementary. That means they're going to add up to 180 degrees. So if this is 81 degrees, then y has to be 99 degrees, because 99 plus 81 is 180. Okay? Now this happens when you have a quadrilateral inscribed in a circle. Let's take a look at number 40. Okay, exact same thing again, so I'm going to go a little faster. All right, here we go. If this is 79, this must be 101, because 101 plus 79 is 180. If this is 97, then this must be 83 degrees, because 83 plus 97 is 180. Now this is only true when you have a quadrilateral, a four-sided polygon, inscribed inside of a circle. Okay? Moving on to number 41, and let's take a look at this really quickly here. Okay, numbers 41 through 46, they're reviewing the following theorems. First of all, let's take a look at number 41. Now, here's what we learned in number 41, okay? We learned that when we have two chords that are intersecting, okay, this angle right here is going to be half of the sum of these two arcs. In other words, let me show you what to do here. When two chords intersect, you can add these two arcs together and then divide by 2. So I have 110 degrees plus 80 and then divide that by 2. And you will get 190 over 2. Divide that out and you will get 95 degrees for your angle. Okay? So understand again, let me erase this and go over this again for you. If you have two chords that are intersecting, you can take this arc here, add this arc here, divide by 2, and it will give you this angle here, which don't forget, vertical angles are congruent, so this angle here is the same as this angle here. So if this is 95, this is 95 also. Okay? Number 42, same thing. I have two chords that are intersecting, and I want to find this angle right here. So I can take this arc plus this arc, which is 90, divided by 2, and I will get 45. So this angle here is 45, and also this angle here is 45 because they're vertical angles and they're congruent. Now, number 43, a little different. So be careful here, guys. Don't be tricked, okay? Notice I have this chord here and this chord here intersecting, okay? So if I take 100 plus 120, I get 220, and then divide it by 2 and I get 110. But hold it, notice it's this arc here and this arc here. So when I add those two together and divide by 2 and I get 110, it's referring to this angle here and this angle here, not this angle here. So when I take 100 plus 120, I get 220 divided by 2 is 110 degrees. So this angle here is 110 degrees right here. But hold it, we know that anytime that we have a straight line like this and then a line coming off of it, this angle here with one dot and this angle here with two dots, those two angles are going to add up to 180. So if this angle right here is 110 degrees, then this angle here has to be 70 because 110 plus 70 is 180. So the answer would be 70. Okay, moving on to 44. Now here's what we learned in this theorem. Let me get a drink here real quick. We learned that when two chords intersect inside of a circle, you can take this segment here. We're going to give this a name and call it E. You can take segment AE and multiply it with segment EC. And if you do that, it will equal, it'll be the same number as when you take segment BE and multiply it with segment ED. So let's go ahead and do that and solve for x. In other words, I can take 2 times x, so 2 times 6, excuse me. So this segment here times this segment here, 2 times 6, and that will equal this segment here times this segment here. So 3 times x is 3x. So next I would have 12 equals 3x, divide both sides by 3, and 4 equals x. Okay, let's take a look at number 45. Same thing. I can take this segment here, which is 8, times this segment here, which is 10. So I'm going to go ahead and write 8 times 10 equals, and then I can take this segment here, which is x, times this segment here, which is 14, or 16, excuse me. So x times 16 would be 16x. So I really have 80 equals 16x, divide both sides by 16, and if I do that correctly, I will get 5. Okay, 5 equals x. One more problem and we're finished. Notice I have two chords that are intersecting inside of a circle, so I can take 10 times 16, and that will equal this segment here, 8, times this segment here, x, and 8 times x is 8x. So I really have 160 equals 8x, divide both sides by 8, and 20 equals x. Okay, and that's it. I hope this review sheet help video has been a help to you. If you guys have any questions, don't hesitate to call or email.